Hey everybody. You guys able to hear me okay? Okay, great. Then let's go ahead and we'll get started. So I just want to start with a few logistical things as usual today. So the first thing, your assignment 2, interesting interfaces, is due tonight by midnight. So if you haven't gotten that in, please go ahead and do that. Are there any questions about that? Okay, if you have questions, just put them in the chat and let me know. Otherwise, that's due tonight. Also, due on Wednesday, your early prototypes for your projects. So that was, previously it was due tonight, but we changed it last class so that it would be due on Wednesday. So that's tomorrow at midnight. Are there questions about your early prototypes for your projects? So I know some of you submitted extra sketches. If I had given you any feedback on your early sketches that you needed something else or an additional sketch or something, I haven't gone through all of those yet. I'm going to do that after this class, but I'll look through this. So the question is, what exactly am I looking for with the prototype? So for the prototype, what I'm looking for is the basic broad layout of your app or your product, whatever you're making, in some prototyping software and some form of interactivity. So the most basic level would be like if you have, a home screen, a settings screen, and some other feature on a separate screen, having each of those screens and then being able to like click a button or click a label and move between the screens. So it would be really basic, it's interactive, and as long as you build it in something that you can send it to me and I can click on it and go between those screens, that's more than enough for this phase. Just really want you to at least try one of these prototyping softwares and build something that has really basic interaction. Does anyone find a good prototyping tool yet? Recommendations? So yeah, definitely people chime in if you've tried one and like it or don't like it. There's the big list of them on Canvas. Kind of the most popular ones are always good to start with. So a few people saying Adobe XD. Yeah, Adobe XD is pretty good. A lot of resources too. So you could probably accomplish a really basic version of this project, quickly in Adobe XD. And I'd encourage you to, turn in whatever you have on your prototype, even if it's more than what the base requirements are for this level. Don't worry about that. As long as it's a prototype and it's interactive, we'll be good to go. Okay. So we'll keep moving. So I wanted to do a little bit of discussion about our reflections. So the reflection was related to watching some of the videos on the Apple developer site related to design. And I just wanted to give you an idea. I looked through all of your reflections today. And I really enjoyed them. I think you guys did a great job. So a few of the videos I haven't watched yet, and you guys really gave me a good feel for what's going to be in the video and whether I wanted to watch it or not. So these were just the most popular videos that everybody watched. I think probably the design with the iOS pickers, menus, and actions turned out to be a really good one for anyone who watched that, in terms of they discuss a lot of the concepts that we looked at in class, and talking about it in the context of changing things in iOS, and I think a lot of you pointed that out. So that was really good to see, and to see how these things play out in kind of the real world on a major platform. And so you kind of got to see a lot of the different trade-offs that like Apple's gone through, and especially they were talking about specifically if they're using larger screens now. So a lot of it was about minimizing the amount of travel that a person's hand has to make to interact with something, or just the sheer visual change that would occur when pulling up different menus. So there's a lot of good stuff in that, and a lot of people pointed out a lot of great things in all of these different videos. So I think that was a pretty good reflection, and you should definitely kind of every now and then just go look and see what different companies have on their design sites. I just picked Apple because it's one that has a lot to choose from, and I wanted you to be able to find something that seemed interesting to you. But certainly a lot of other companies also have that. So last time we were here, we talked about using web technologies to do UI development. Specifically, we talked about HTML, and we talked about CSS, cascading style sheets, and then we talked about JavaScript, and linking all of those together in a really basic level to get an idea of what you can do with web technologies. So today, we're going to kind of jump a little bit out of the sequence of things. We've been talking about prototyping tools and then kind of about how you can build things with the web. But today we're going to just do a survey of different types of interfaces. There are a lot of different interfaces that are possible today, and we kind of want to make sure we get a good overview of them. So first of all, kind of the question you might ask is, how would you classify interface types? And you could do it in a lot of different ways. You could think about the function of the interface, the style of interaction, the device that's used, maybe even the platform that it's on. We're going to break it down, a lot of it with function and interaction style, but there's definitely overlap. So you can have a single type of interface that could be classified in to multiple categories, and we'll see that today. So a few interface types, just to name some. So I pulled this list from the Interaction Design book, and it's kind of you could see immediately how some of these overlap with each other, right? A graphical interface and a touch interface, if you just have a tablet, well, you've got both of those happening right there. But these, we'll go through, we'll touch on a little bit on all of these different categories. And I'll start roughly kind of chronologically, but that will, quickly, we'll get to a point where everything exists at the same time. So if you have questions as we go or comments, just let me know. So let's start with command-based interfaces. So this is kind of, where we started early on in the history of computing, and still where a lot of us spend our time when we're, writing software or working with systems. And these are just interfaces that are based on typing commands and reading an output, typically. So here I've just got an example. This is just a terminal window, and I'm running a command in it, and it produces an output, and then it's ready for me to run another command. So when we think about command-based interfaces, they're some of the earliest interfaces. And one example is like a terminal window, like I've shown you there. But another thing you might want to think about for a command-based interface like keyboard shortcuts. Those are kind of command-based interfaces. Control-C or Command-C for copy. That's just a straight-up command-based interface. There are also some commands that are, anchored in like the physical keyboard itself, right? So like the backspace or delete key, right? Those are on the keyboard there. They're anchored into the hardware. In a similar way, you might have single key shortcuts, so like the function keys that we have on most of our keyboards. They'll be mapped to different things depending on the application. You can also have programmable combinations of keys, right? So we see that command-based interfaces are still used a lot. A, for software developers, programmers, and B, for a lot of what we would call like expert user applications. So if you use like Adobe Editor for photos or video, you probably learn some of these command-based shortcuts. So like if you're in an Adobe product and you press the V key, that will usually give you an arrow or a selection tool, and that's kind of universal. Another area where this happens a lot is like CAD, 3D design. People learn these modifiers and these quick shortcuts because it speeds up their workflow. So it's still, an important interface to design, to think about, especially if you're going to have users that want to do things quickly. You'll want to consider adding kind of those faster paths and those shortcuts. Another thing to consider, though, when you're designing that is kind of what are the system level shortcuts, right? And watching out for conflicts with those, so thinking about where your software is going to exist. We also have some command-based interfaces that you might not think about that some of us use. So if you're searching like on Google, right, you might use some modifiers on your search, like a file type. You might say, I only want PDF files. You might limit it to a domain by using like site : and then the domain name. So that's not really expert software, but those search query modifiers are command-based ways of interfacing with the software. So of course, after command interfaces, we've moved on pretty quickly to graphical user interfaces. So this is just a screenshot of my computer earlier, and it's I've pushed into, I don't know if it's still called this, Mac used to call it expose mode, and you just make a gesture and it throws all your windows there so you can see them and your workspaces, and you can hover and quickly switch app to app. Most operating systems have ways of doing this. Some of them have some keyboard shortcuts, some of them have gestures, usually a mix of both. But the whole idea, as I'm sure we're all painfully aware, with GUIs, we started with Xerox Star, and we got into this whole thing with windows, icons, menus, pointers, right? So we've got windows we can move around. They contain the applications. You interact with them. Early designs and still current designs, really put a focus on the windows themselves, on different form elements, we usually call them, so like scroll bars, checkboxes, panels. There's a big focus on composing things into widgets, right, or components that are reusable. And I think I did want to mention, for those of you who watched the one of the iOS video about the date picker that they designed, the new one for iOS 14. There was a segment in there where they talk about making it show up when there's not much screen real estate, so it simplifies it to the little summary that's just a shortened date, and then when you click on it, it expands out that component. So one thing that's kind of important to think about when you design a component or a widget you're going to use multiple places is how could you scale it, if your user is running low on real estate or they're moving something else to focus on it, still represent it but in a smaller way. So that's pretty important. And when we get GUIs, we start to have the input of the mouse and keyboard, and then we have other pointing devices basically. Eventually we moved to touch devices, direct touch and indirect touch. So like, if you're a trackpad, that's more of an indirect mapping. But if you're on like a tablet touchscreen, that's really direct. We also see concepts like toolbars being pretty common, docks. On just a traditional GUI, hovering over something to get like an alternate description of what the tool does. So we see things represented as icons quite a bit, and the hovering becomes important, which is also interesting when we switch over to like the touch-based interfaces where you can't necessarily map that as easily. So looking at windows and menus specifically, we've kind of arrived at this idea of having these viewports that scroll. One of the big problems, but challenges when we started to really use these systems is how do you manage windows? How do you find the correct window quickly? So, you've got things like Alt-Tab, Command-Tab, things like the gesture I mentioned earlier to show you everything, to move between things, right? And then we also start to get things like virtual desktop spaces, so you can have, like on the Mac, I can have a bunch of desktops, and I can use a gesture to swipe between them, right? So I can have all of my programming stuff in one, and I can have, all of my my Gmail and my iMessage or whatever in one, and then maybe like presentation stuff in another. And then I can just have kind of separated spaces. And then, if you have additional physical monitors, you can map those spaces to those monitors as well. So we start to see that happen. Menu design becomes a huge thing. And so there are several types of menus, and you've used all of them. Basic flat menu where you just kind of have everything there to choose from. Just kind of similar to a palette almost, but usually it's written out as text. You've got expanding menus, which is what we're familiar with, like drop-down kind of menus. And then you've got cascading menus, which actually turn out to be quite involved in terms of the different layers of, if you ever go down a drop-down and then you go over and over and over. It's actually easy for that to be a bad user experience. And if you think about some of the things early on, we talked about like Fitts law and Steering's law and trying to target small things. So there are a lot of different approaches to menus that try to compensate for the user having to navigate way down those menus. And I'd encourage you to just go play with the menu and see how it actually responds if you move over at the wrong time or do something non-intuitive. Different systems have different boundaries in terms of where they allow things to cut off. So we also see radial menus or pie menus. These are pretty popular in design software still. So the idea being like you put your mouse or your pen down, and then the menus scroll out around you, and you can choose a pie and then keep going out. So then you can turn your commands into a gesture as well. Makes it faster. So that kind of is where we go with menus. Icons, though, icons are something that really persist kind of across everything still. So an icon's really useful because it allows you to take and use a small amount of screen real estate to represent something. But as far as deciding, what an icon, if you want to represent some function, what icon is the best icon for that? We first usually look to convention. Is there something that we already is established and well known as being the icon for that, right? So a play icon, right? That's a triangle. We're pretty used to seeing that specific triangle. The save icon being like the floppy disk. We're pretty used to that. But it gets a little more tricky. If you want to have an icon for some kind of adjustment to a photo, right? So there are some standards for brightness and contrast and different adjustments, but you can get to a place where you've got to make choices, and those choices need to make sense to the user. You also will see conventions within platforms, a set of icons that certain ecosystems or platforms want you to use. We'll see icons that are, some of them very photorealistic, and then others that are very flat. And this is kind of a style thing that just changes over time. But you could definitely use those to your advantage. So one example is in an earlier version of Mac OS, and I'm not sure if it's true today, like all of the utilities, like the system preferences, terminal, console, window, all of those icons were very kind of used one or two grayish colors, and they were very straight, simple little icons. Whereas all of like the Photos app or iTunes or whatever, were very photoreal and 3D colorful icons. So it kind of allows you to do some selection cognitively in a quick way with the icons. So icons are really important in terms of graphical interfaces. But let's keep moving. Let's talk a little bit about pen and stylus interaction with the screen. So here I've just got a random iPad with first Apple Pencil, but there are a lot of platforms that use a stylus or a pen input. And one reason that this is a kind of early on became a useful input device is because people are very used to using it to write on paper or to draw on paper. Kind of we grow up accustomed to using a writing device. So it's a pretty intuitive, direct mapping. So thinking about that, you can use a stylus or a pencil to do pretty much everything you can do with the mouse. You can do it for your pointing, selecting, but you can also do things like actually do handwriting, drawing and sketching. And this isn't limited to just, like a tablet with a stylus input. We've also got some things like the smart pens that, that's a pen that writes on physical paper. It might be a special grid paper or something, but they'll use different techniques so that they save a digital version of what you're writing through the pen, so that you can have that preserved digitally. That's also an interface that uses a pen input method. So when we start to talk about using a stylus or a pen, the area of research in HCI, kind of the sub-discipline there, is an area called sketch recognition that is a really interesting area, and it deals with how do we get the computer to understand people drawing or sketching different things. So something as simple as distinguishing shapes can be quite involved. You can also think of a pen or a stylus input as being a gesture device. So because you get a series of points over time. Also with most modern pen inputs, you'll get a level of pressure depending on how nice the pen is. You can get the different angles that the pen is at. You can get a lot of different characteristics that would allow you to modify the user's input based on that. So it's really great for like apps where you're wanting to like sketch something, or if you're really an artist, and you want to mimic kind of the different properties you might get from a real pencil or a real writing device. That can be done with the extra data about kind of where the pen or pencil is and how it behaves over time. So we also see this being super useful, obviously, for taking notes, annotating things, and also it's just a really precise pointing device for direct manipulation. So if you remember, or if you've looked at the history of kind of like modern smartphones, starting with Apple's big push for their iPhone, and they, famously made a choice where Steve Jobs said, you don't need a stylus, you just need your finger. That, and that was a big thing for them for a long time. And it took forever to be able to get a pencil, and it's still not great, I would say. So my complaint about the Apple Pencil, both this one, the first one, and the second one, is that I really like to have it where you can just turn it over and erase, just like you would a regular pencil. I've used Microsoft Surfaces for a long time too, and that's a feature that they've kept for a while in most of them, and it's really convenient and really intuitive and natural, but Apple refuses to do that. So anyways, that's just a side rant about pencils, or styluses. So can be really useful in whole areas of computing, around that. Also, a nice thing about stylus or pen input is that it doesn't always, it doesn't depend on capacitance necessarily. So a lot of our modern touchscreens are capacitive. They use capacitance from human skin, which gets disrupted with, dirt. It gets, you can't use it through gloves or other things. There's, issues to deal with there that the stylus gets around. But also, you've got to keep up with the stylus. So definitely a trade-off. Well, let's move on to touchscreens, mobile devices, another big area that we see today. Just seems to get more and more popular. I think that's just a recent iPad and iPhone, but we definitely see that becoming kind of the most prevalent device, and certainly the device that everybody carries with them is based on touchscreens. So the basic principle of the touchscreen is that you're able to see, the user's able to directly touch something, so that direct mapping is there and has a nice affordance of being able to do direct manipulation and be a little more intuitive. Bunch of different types of touchscreens. Most of the ones that we use today are capacitive touchscreens. They're multi-touch, so they can track many touch points at the same time. We'll talk about in a few slides big collaborative displays that are touchscreens, so multiple users using the same display. But they also allow the use of gestures. And we see this not just in touchscreens, we also see it in trackpads, touch surfaces, right, that are not the screen themselves. But allowing, a movement over time to have meaning in your interface. So some of the challenges historically with touch screens is kind of another early on thing, when smartphones became a big deal, was the idea that people weren't quite sure that we were going to be okay without a physical keyboard on like a mobile device. The idea of a soft keyboard was problematic, and it took people adapting to it before everyone was okay. But you don't have physical tactile feedback on a touch screen, right? So you have to account for that in your design. And there are a lot of tricks that are done, and you can certainly work in some tactile feedback, whether that's through haptic, vibrations, or there are some more complex methods now that let you really kind of distort the physical nature of a display, even where a user's touching it. But in general, that's one of the big challenges with touchscreens, is that it's not something that you can manipulate and feel the feedback of it. So also, I mentioned earlier, interfaces that are built for a mouse traditionally sometimes have touchscreen problems. So like those hover events don't necessarily map because you can't hover. So you kind of have to interpret that differently. So thinking about mobile devices, we can think about phones and tablets. Kind of what's unique about mobile devices, which we have. Sorry, just a second. Okay, we have. These mobile devices, they're all touch-based, as we just mentioned. But the mobile device kind of environment also has a lot of sensing ability, whether that be, a user's location in the world, or, just, how are they like holding the device? Is it rotating? Are they holding it up, moving it around? Things like that. And give it a little bit more sensitivity to what's going on around it. So, traditional early computers, they lived in a physical location usually, then kind of had laptops and portable things that people moved around with them. Mobile devices, by definition, are usually something that a person carries with them and that they consult regularly. So the other side of that is that they're usually small, have power constraints, right? Processing power constraints. They're battery powered. There are limits on that. And then you also have to think about, mobile devices are usually right next to their users. So that brings up a lot of concerns in terms of privacy, in terms of security, things that we may not think about on other devices in quite that same way. So those are some considerations there. I'm going to briefly touch on a category that we'll call multimedia. It's a broad category, and we'll talk about it in detail later. But this is just any interface that includes video and animation and text and interactive elements. Traditionally in HCI, we've talked about interactive books or museum exhibits, but there are a lot of interfaces we use every day that are definitely multimedia, like Google Maps. If you think about, if you ever read like a news article and it's got like a visualization that's interactive in it, that's a multimedia interface. Here's an example of one. Let's see if that's, oops. I'm not sure if that video is going to play. This is just a piece of software, a graphing software that's installed by default on Macs. And you can put in an equation and you can render some 3D thing and you can inspect it. So let's see if I can get it to play the actual animation. Oh, I guess not. Okay. So we'll talk more about multimedia in another lecture. So let's move along to voice user interfaces. So this is one that's become more and more common. We see it in many places. The idea being we're going to just use spoken language because that is the easiest thing for a user to do, since that's how we communicate with other people. So today you can find it in pretty much any computation device, but we also have these dedicated hardware devices that we use for it, most of them in our homes. So the different home assistants, Google, Amazon, the idea being that you can just, call out to these devices, and then you can ask them to do something for you or to give you information. Originally, voice user interfaces were really constrained because of how bad we were at recognizing speech. So you might only be able to choose yes or no, and that was kind of a technology problem that we've since dealt with, and we're much better at it today. There are still some very specific design considerations when you're thinking about doing a voice interface, and I think that if you think about the frustrating experiences you've had with a voice interface, you can pretty much enumerate most of the design considerations. Big one being you need to let the user be able to interrupt the voice agent. You need to have your voice agent give feedback that's appropriate on what it understood. So if you're asking it to set an alarm at a certain time, it needs to speak that back to the user in a way that they're likely to catch it if there's an error. In some cases, the voice assistant is coupled with a screen, so you can also show it on the screen, which can give you a little bit more redundancy there. And you also have to consider something as simple as what synthetic voice do we use, for our voice assistant or our voice agent, and that can be an area that really matters a lot, depending on who your users are. Some other issues that come up with voice interfaces, we tend to do everything in the cloud these days. We kind of just we'll just offload it to the cloud, and so that's fine as long as you have the cloud there, and you can get to it quick enough, and you're okay with it hearing recordings of your user. But if you're not, then there's a whole other set of constraints that you have to work with if you're going to try to do this this kind of interface just on a user's device locally. So we've also got privacy constraints. You've got to think about languages, accents, different ways of speaking. So children are still difficult to do voice recognition with and do voice user interfaces. And then you've also got a challenge in terms of context. How aware is the agent of what the user's context is? So how long of a chain of conversation can the user have and refer back to something? And this isn't necessarily a UI issue. In a lot of cases, this is an AI issue. In that you've got to understand what's being said and kind of be able to map that out. But it's something that that matters to the user experience there. So move right along. Virtual reality, another kind of distinct interface. It's been around for a while, but recently has made quite a bit of progress. So the whole idea being with virtual reality that you're creating an immersive experience. You want the person to feel like they are wherever, in whatever environment you're placing them. Today, a lot of the most popular solutions are headset solutions that you wear, but there are also other ways of doing it. So there's something called a cave, which is basically a bunch of large screens that surround you and make you feel immersed in an environment. You can do a lot of things with projection also to do that. But one of the big ideas is that you want to visually immerse the person in some world or environment that they're not actually in. And when you do that, you might start to incorporate other feedback mechanisms. So like haptic feedback, like vibrations or tactile senses, can be really useful when you're doing a VR kind of experience. You can also rely a lot on sound, and you can even do things like placing the user on an omnidirectional treadmill platform, right? So they can walk in place, and you can change the resistance and kind of really give them the feeling of physically being somewhere else in a different environment. And kind of the big idea with VR is you want to allow people to take on different perspectives. You want them to feel present in this other environment. And this has a lot of applications. So we see a lot of gaming applications, obviously, but also if you think about like education and training, VR is used a lot in different domains to help train people, especially if the environments that they need to learn about are not necessarily the safest for them to go learn in when they're new to the environment. VR can be helpful for kind of safety and eliminating risk in that sense. Also, VR is quite useful for therapy. So we definitely see it being used in therapeutic ways. So if you think of a case where someone develops an anxiety or a fear of leaving their home, for example, and maybe there are different things that kind of trigger that fear, that anxiety and sense of panic. One common one is kind of just crowds of people or different things like that. You can use VR to simulate the experience of going out into a crowd or going into public to kind of help someone work through that irrational anxiety that's built up and is causing them trouble. Yeah, so a good comment. They use it in the military. Yeah, so a lot of military use of VR. So training, especially if you want to, you want someone who's in the military to feel what it's like to be somewhere they're going to go. And VR won't replicate it perfectly, but it gives them a great opportunity to see environments and play out scenarios that otherwise would be difficult to do. So yeah, that's a great training example. So VR is really a interesting area, a really fun area, and just a lot of technical development going on in that area right now. Now, related to VR, we've got AR, so augmented reality. And so here we've got two pictures. One on the left is the Google Glass from long ago, and then on the right is a version of the Microsoft HoloLens. And the idea with augmented reality is that you're allowing the user, instead of creating an entirely fake environment for them to go to, you're taking their physical surroundings and augmenting them, right? So this brings with it a different set of challenges, technically. You need to be able to map and understand the world that the user's in, and then you need to have technology to be able to overlay things into that world. And we also see this, not just with headset devices. We see it with mobile devices. One of the most common applications that we see, for better or worse, is photo filters, right? So any of the filters that you might use on Snapchat or TikTok or whatever, those are augmented reality interfaces. And also, I should say, we had a huge popular game like 4 or 5 years ago, Pokemon Go, right? That was an augmented reality interface. So putting elements in the world that weren't actually there, you're seeing them through the device. This is also really great for training, education. It can be useful, like if you think about, I don't know, like if you have a big factory or a big industrial plant, and say they've got like lots of pipes or wiring or stuff, that they're using in their processes. You can, they already have like models and maps of what everything is, but you can add some augmented reality glasses, and someone walking around can then look up, at a pipe, and it will be labeled, right? Because it's got a spatial mapping of what it is, and that can be really helpful in, helping someone, troubleshoot something or fix something more quickly than they could previously, because they're not having to reference a lot, and it's putting kind of a direct interface on the world for them. So another interesting and somewhat emerging area is the idea of brain-computer interfaces. Whoa, that's like interfaces not spelled correctly there. I'll fix that. So brain-computer interfaces, BCI, is the idea is that you use some sensing technology, and it's usually technology that's similar to what we see in like EEGs that are used in the medical world, and we'll kind of measure changes that occur in the brain, so brain waves, if you like, and if we measure at different points and we're able to distinguish different patterns, we can map those patterns as an input to something. So there are really expensive ways to do this. There are really cheap ways to do this. The example I have here is a project called OpenBCI. It's one of the really affordable ways to do it. And there are some commercial, just off-the-shelf ones. This one's, you assemble it yourself. And it's got open source software and stuff you can use. But there are some that you can just buy and wear, and they have like an API or something to get the signals out of them. But essentially, what you're doing is you're capturing signals and using them, mapping them as input. So this does require a little bit of training, both on the user side and the system side, kind of to map those things. But it's definitely something that has a robust effect, definitely for simple things like moving a cursor or a pointer. And it's really powerful when you think about what that can do for somebody who doesn't have the ability to physically move a cursor or type. Or even you can map this not just to software but to hardware. So if you look at some of the different prosthetic devices that might use either BCI or some other nerve signaling sensors to like move a prosthetic arm or hand, so that someone can have that ability to manipulate the world using that prosthetic device, but just by thinking about what they want to do. And like I said, there's training that has to occur here in terms of there's no straightforward mapping that just works out of the box for everyone. And it's definitely an area of ongoing research, but it's an area where we've seen a lot of success. And we've also seen some interesting, I guess, commercial proposals in terms of using this. I believe Facebook has a couple of proposals about using kind of BCI techniques to assist in the user inputting text. And I believe also one of Elon Musk's companies has some work in this area right now. So it's an interesting area. Also, I mean, I should say it's an area that has some ethical privacy concern. That's kind of a thing that's developing, I guess, as we get better at this. Obviously, people get concerned when you start to say that you're reading minds or brainwaves, about the voluntary nature of that. The comment is BCI and VR would be cool combined. Yeah, definitely. And I'm certain people are playing with it. There's probably some research papers at the very least out there that have looked at that, because it's really cool. So it's something that you'll see more and more of. You'll see more things develop in this area. So also have this is a screenshot of that headset. So it's only like $350, right? To get up and running with that one. That's not too bad. So can I move on to the idea of haptic interfaces. So vibrations and kind of advanced touch, I'll call it, but being able to have touch sensing in other ways than just screens. So one interesting idea is like the thread in clothing, using a capacitive thread to actually allow all clothing to be mapped as an input device. So there's Google was working on a Project Jacquard, to do that in partnership with Levi, I think. But it's definitely an interesting way of capturing touch. Haptics we're familiar with, basic haptics, just little alerts that we might get on our watch or our phones. And it's just giving you a tactile sensation, right? Using a motor or an actuator. You can get a little more advanced with this. You can actually do some things to change how someone perceives a surface. Like, is it a rough or smooth surface, by oscillating things at certain frequencies. There are things like current Apple MacBooks. The trackpads don't actually physically click or move. It's all haptic simulation, but it's very convincing. And so you could see how that can scale out to using haptics to kind of give a sense of touch. You also have things like force feedback mechanisms, so that the system can kind of guide a user. It's really useful for real-time applications. I also wanted to mention this ultra haptics. I've got a little screenshot of it down here. It's using ultrasound to kind of create a touch sensation in the air, so you feel like you're interacting with something. It's really interesting. It's been something they've been working on, I think, over the past 10 years. There are some products attempting to use it. Some questions that come up with haptic feedback, obviously, where are you going to put actuators, especially when you're thinking about if it's something a person wears, and then how often can you use haptic feedback before it's a problem or before someone doesn't realize it's happening. Also, you kind of get these effects, you get like phantom vibration effects. So if you've ever thought that your phone buzzed in your pocket or your watch buzzed or whatever, and then you realize you're not wearing your watch or you don't have your phone, that's phantom vibration. We kind of have grown accustomed to tending to those haptic alerts, and sometimes something will fire that response in our brain, even though the haptic sensation didn't actually happen. So that's something to think about in this area. Related to this, wearables are kind of another interface category, I guess. So most common one we think of is a smartwatch or a fitness band, but it's a big group of devices, right? So like the Google Glass device is technically wearable. Snapchat's spectacles, their glasses, the cameras, those are wearables. We see things like smart jewelry, so smart rings. We see smart shoes, like that have sensors in them to track things. I mentioned the clothing earlier. We also see display technologies starting to get to a point where they can actually be integrated into clothing and stuff. So a lot of interesting input-output being done kind of with wearable items. Some of the big design challenges in the wearable area come in terms of comfort and safety, number one. So, if you're putting sensors or actuators into something that's worn, you are concerned about the user's comfort. So especially because you need to power these things usually, where are you putting the power source? How is that working? And then also, obviously, if you're going to be running electronics on someone as part of their clothing or something, safety is a concern as well. Another issue that comes up quite frequently is the ability to wash or clean something when it's wearable, right? So we see some different approaches to this. So like a lot of the watches or fitness trackers, they will have discrete components, like maybe the band that goes around you, or will be separate from the actual computation part, so that you can, in the worst case, replace that or remove that and clean that part, but not the sensitive electronic part. So it's an area of concern when you're designing these wearable devices. This is something that I deal with a lot in the research I do with Therabot, which is the therapeutic robotic stuffed animal kind of dog. So it's meant to be used in therapeutic scenarios, kind of like a stuffed animal, but obviously it's got a lot of sensors and actuators and electronics within it. And so kind of the design for that, you have to consider all of these things, especially because it's its target use is kind of in clinical applications and healthcare settings. So there are concerns about, you need to be able to clean it, right? And you've got to think about that in the actual design of these interfaces. And another thing I should say is that if you can make these things washable, right? But you've also got to remember that if you're using something like a conductive or a capacitive thread or something within the fabrics, the lifespan of them is going to be different. And so that's something that when you design a product, a solution for people, you've got to really think about how do you communicate to them that the lifespan of this piece of clothing is different than what they're accustomed to. There's a good example of this with the Roomba vacuum cleaner, so the robot vacuum cleaner. When they initially set out to build it as a product for people's homes, they did the engineering and estimated what the durability needed to be for it to last for so many years, and they used the data of how frequently people vacuum their homes. What's the use of a vacuum cleaner like? Unfortunately, it turns out once people got their cool little Roomba robots, they were more willing to tell them to vacuum very frequently than in comparison to the data that they based everything on in terms of how frequently vacuuming occurred. So a lot of those early Roomba robots did not have the correct durability built into them, and they had shorter lifespans than expected in some cases. That's one of those lessons that's not always obvious as you design something, but you've got to think about what is it, if it's replacing something or if it's something completely new like that. There may be something different that occurs. So I'm going to talk a little more broadly about gesture-based systems. So I mentioned gestures earlier when I was talking about the pen input or the touch input. And here I've got two examples. So on the left, we've got the swipe keyboard, which is a software keyboard where you put your finger down on the first letter and you kind of just drag through the letters of the word that you want, and you're able to quickly do input on the soft keyboard this way. So I think this used to be called, the research project was called ShapeWriter, I believe, and it falls in that area of sketch recognition in HCI, and so you're following this stroke over time, and you're using that to input this word. Now, kind of completely separate from that type of gesture recognition, on the right here, you can see a surgeon using, I think it's a Microsoft Connect probably, or an early version of that, to use gestures to control the interface in an operating room. And this is, obviously really useful because when you're in surgery, you're in a sterile area, you cannot necessarily interact with these devices, right? So usually, you would have a proxy person who could do that for you, but that puts one more link in the chain there. So this is a solution that allows kind of these bigger gestures to be used to interact with an interface. And of course, this brings along its own set of challenges. So we can think about some of these. So first of all, you've got to have a sensing platform that can sense the gesture. Now we've got a lot of choices today in terms of what we can use to sense. We've got some pretty good sensors that can actually use time of flight techniques or radar techniques or in some cases just projected pattern structured light to get a 3D image of what a user's doing, so to get some depth in addition to just the 2D visual projection of what's going on in a scene. And that can be helpful on the side of, tracking someone's hands or, determining their posture or pose. And so Microsoft Connect is a great example of that. Intel has a line of sensors, the Intel RealSense sensors, that they're in a lot of laptops now. They're in some tablets. You can get them as standalone kind of webcam-like devices. We also see it built into a lot of phones, some type of depth sensing technology. It's the same stuff that's usually used to, make facial recognition better, more robust in terms of being a security authentication mechanism. But these same sensors are used to recognize gestures. We can also use just touchpads or capacitive screens. You can also use just a regular color vision or IR vision camera, right? And use computer vision to track what someone's doing. But then you've got the challenge of mapping that into whatever interface it is they want to use. So this is one of those areas where targeting, again, is a big deal, right? So I mentioned earlier, like one good thing about the stylus is you can be really precise. Gestures are kind of not, they're kind of, in most cases, worse to deal with than a direct touch, because usually the person is making a large gesture that's mapped to a smaller area. And so you've got to account for that feedback loop and for their ability to target or navigate whatever it is that they're doing. But it works great for some things. You can imagine like large interfaces, like you want to just swipe through something on like a TV screen. Yeah, if you could just do that, that's cool. And that works well. So there's also this challenge of developing a language of gestures or a vocabulary of gestures, depending on your application. So like culturally, we have gestures in different places of the world that mean different things to us. We learn them as we grow up. A lot of us wave at each other over here as a greeting. But beyond just kind of what humans have, human to human, you have to think about, what should a gesture look like in a specific domain for a specific purpose. So that's something that, you have to be concerned with in this. I'm going to show a video, I hope, that's a gesture-based method for controlling a swarm of robots. So let me see if this will play. Okay, so that's pretty good. Disney Research does some really fun stuff, but that's just showing a lot of a variety of things you could do using these gestures to control the swarm of robots. It's just a pretty fun way of doing that. So let's talk about briefly tangible interfaces. So these are interfaces that use physical real-world objects in combination with a digital system to allow you to manipulate the physical thing, but also have that represented in the digital world. And it's kind of a blending of those two environments. So I'll show you an example of that. Very dramatic. But you can see that these blocks are sensed by the surface they're on. And they're kind of, you know, reacting to that. So that's a tangible interface. Jumping over to another important type of interface are shareable interfaces or collaborative interfaces. They can be things as simple as Google Docs, where, you know, people collaborate together at the same time and work on, you know, a document together. But they can also be something like a smart board or a, you know, smart display, where multiple people can actually, you know, draw on it like it would just be like a regular surface. And you can use that for collaborative things, or even just, you know, using one display to allow multiple people to use an interface. So that's a whole nother area of design. There are a lot of things to think about when you've got multiple users, especially if they're interacting with the same data. And how do you handle that, and how do you make them aware of each other, especially if they're not physically located together. I'll show you one interesting interface. This is it's called a reflect table. It's to visualize ongoing conversations. And so it's kind of a collaborative interface, but it's also kind of this
Reflect is an innovative, easy-to-use and fun tool for efficient collaborative training and meetings. It detects the sound positions and shows who is talking through lightened LEDs on the tabletop, and at the same time visualizing conversation dynamics. Reflect shows each speaker's current participation level and the distribution for the entire conversation. The speech path tracks the way of the conversation and its intensity between people by leaving a trace. Reflect also features interactive voice-controlled games. The speech analysis shows the different moods of the participants. Using Reflect, you can detect dominant and passive group members and make people aware of their own and others' communicational behavior. Reflect is also an ideal tool to be used to enrich interview activities, negotiation training, and conflict management.
So it's kind of an interesting idea, right? You know, it's going to tell you who's dominating the conversation or something. But it's an interesting collaborative interface, or even it's almost a tangible interface because it's interacting with the sound. But you know, that's kind of a unique example. I'll show you one more that's really interesting, and this is a video conferencing, an early video conferencing system, and I think it's pretty impressive for its time. You guys aren't getting audio? Okay. Sorry about that. These are better with audio. I'll just go ahead. Oh, you've got audio for the other ones? Well, that's really weird. Okay. Not sure. But I've got it linked in the slides, so if you want to watch it, it's really interesting just because it's very old, but you know, it's kind of got these physical telepresence concepts going on. So before we wrap up today, briefly we'll address a few other interface types. So appliances and Internet of Things. We'll talk more about this. I'll move myself out of the way. That's a toaster that you can print things onto toast with. But obviously all of these things have interfaces, and we're adding more and more interfaces to them because why not? Important things to think about is, how are these things going to function if they don't have a network connection? What happens when the company that supplies the back end goes bankrupt? What's the failure mode there? So we'll talk more about that in another lecture. We'll also talk about robots quite a bit in a separate lecture, so I'll skip over that. Briefly, wanted to say that obviously you can combine all of these different modalities, right? And that's kind of ideal. So that makes a great user experience. Typically, you can really get a much higher fidelity, much more enjoyable interaction if you design it right, if you use a combination of these things. And then there's kind of the idea of using these things to create a natural user interface. And that's an interface that allows people to not actively notice they're computing or interacting with a computation device. So it's a goal that's set on reducing the amount of learning needed to enter a system and make it more intuitive. It's a design goal. It's a usability goal. It's difficult with more and more complex tasks. So there's a balance there. As far as which interface to choose, got a few factors. We've talked about this before. It's always a combination of what's available, what gives you the functionality, what fits the social needs, the problem needs, and we'll talk about a few of these in detail in other lectures, and how you design for those. So that kind of sums up our crazy quick tour of all the interfaces and common interfaces that are out there today. Action item wise, you've got assignment 2, which due tonight by midnight, and then tomorrow your early prototype is due by midnight. We will meet on Thursday. I don't have the lecture name on here for some reason. We're going to talk about usability testing and user testing on Thursday. And you will have a quiz that will be posted Wednesday, and it will be an easy quiz. It will be about HTML and JavaScript. So that's everything I have. So next time we will meet WebEx for usability and user studies. That's everything I've got. If you guys have questions, go ahead and throw them in the chat. All right, you'll have a good day. I'll hang out here for a couple more minutes if anybody's got anything, but otherwise I'll see you all on Thursday.